In your experience as a student, you might have come across concepts such as the laws of thermodynamics, Newton's laws of motions, or Kepler's laws of planetary motion. Did you ever stop to think why these concepts are called laws? Are natural laws at all like the laws in our society? And how are laws different than theories? Natural laws are not like laws in our society. Societal laws define conduct between human beings and are determined through governing bodies. Natural laws, on the other hand, are determined by fundamental forces within nature. Natural laws arise from the process known as the scientific method. The scientific method is the systematic study of the natural world through experimentation and observation. This method provides scientists with a rigorous framework to objectively study the natural world. Using the scientific method, natural laws can be verified through experiments conducted by independent observers. Many different natural laws have been described over time, but all of them have a common link. In science, a law is a concise description of a natural phenomenon. The law can be a simple statement in words, as well as a mathematical equation. When natural laws are mentioned, one of the more common scientific disciplines that comes to mind is physics. Laws in physics include concepts such as Newton's law of universal gravitation. This law describes the attractive gravitational force, F, that exists between two masses, m sub 1 and m sub 2. Here is the law of universal gravitation expressed as a mathematical equation. Another example of a natural law in physics is Ohm's law that describes the relationship between voltage, V, current, I, and resistance, R. Natural laws are also found within chemistry. One of the most important laws in chemistry is the law of conservation of matter. This law states that matter can neither be created nor destroyed. This law establishes the foundation for understanding chemical reactions, since matter in reactions is just recombined to form different combinations. The law of conservation of matter predicts that the same total number of atoms are present before and after a chemical reaction. Biology, too, has laws that describe natural phenomena. One excellent example is Mendel's law of segregation. This law describes how physical traits are passed from one generation to the next. The difference between laws and theories is often misunderstood. The crucial misconception is that theories, after rigorous testings, can become laws. This idea is false because it mistakenly assumes these products of the scientific method are connected to each other. The scope of a law is limited to description. Laws describe a relationship between phenomena. They explain how something works, but do not seek to explain why the relationship is there in the first place. A theory is an explanation of the relationship between different phenomena, as well as the underlying causes of natural phenomena. The explanation from a theory goes far beyond simple description. In other words, theories tell us why something happens instead of just how it happens. To better illustrate the point, consider our understanding of gravity. The basic attraction between two masses is described by Newton's law of universal gravitation, as shown previously. This law, however, does not address why masses are attracted to each other in the first place. Einstein's theory of general relativity provides the explanation for gravity as resulting from masses warping the fabric of space and time. Natural laws are concise descriptions of natural phenomena. Natural laws, like theories, are products of the scientific method. The scientific method is the systematic study of the natural world through experimentation and observation. While theories describe the causes of natural phenomena, natural laws only describe the relationships between natural phenomena. Natural laws can be found as simple statements as well as mathematical relationships within all of the natural sciences.